die. Just like in a nuclear blast. Yet, nothing about these rocks in the news yet. So you ask me, where would they hit? That's a tough one. But let's try and make an educated guess. NASA says, they will all miss Earth, all three of them. But do they actually account for Earth's gravitational pull on these rocks? The problem is, all of these three new asteroids have very similar trajectories to Earth. So when they come flying by, that makes for a lot of time for them to get pulled in by Earth. They can come even closer to us than the Moon. Keep in mind that the Moon is much bigger than these asteroids. And yet it's kept where it is because of Earth's pull. So if Earth exerts that much force on the Moon, imagine how much force it can exert on an asteroid. Even if the asteroid is going fast. Let's find out if NASA accounts for Earth pulling on these asteroids. I think you will be surprised. First up, 2011 ES4. Here you can already tell from afar that we've got a dangerous situation. I wanted to show you an overview first of where things are at, literally. This is the situation right now as I'm making this, 23rd of August 2020. I'll zoom in slowly here. You will always see the date and what time this is, in the bottom left corner. Have a look for yourself. At this point in time, we're getting very close. There, I'll stop the zooming now as this is clear enough for now. Let's call the asteroid ES4 for short. Look at how ES4 passes by us. It's so close, it comes even closer than the Moon does. Each position is 6 hours later than the previous one, and I've stringed all of them along. Did you miss it? Let me play that back for you. If you're thinking to yourself, well, that looks like a straight line. Then you are correct. It is. Putting all of NASA's positioning data together, you get the red line shown here. It doesn't bend anywhere to account for gravity. Yet ES4 comes closer than the Moon. Well, let's now plot this ourselves on the NASA map, but accounting for Earth's gravity to fully pull ES4 in. You saw that per 6 hours ES4 travels a certain distance. That's the green arrow. Measuring this will differ depending on with what screen you're looking at this. On my screen, for example, it's 2.9 centimeters. But anyway, ES4 travels the length of that green arrow in 6 hours time. Now the orange curve is the worst case scenario. I am assuming this starts about halfway the first 6 hours of passing the Moon's orbit. When I measure this orange curve with a piece of string, it's 4.5 centimeters or 1.552 times the length of the green arrow. This means it will take 3 hours plus 6 hours times 1.552 to the supposed moment of impact. That's 12.312 hours. Actually, let's make that 12 hours. Because ES4 will likely speed up a notch, as Earth's pull will allow it to travel more effortlessly. This means that our estimated hypothetical impact time would be 1800 hours UTC, September 1st. And where exactly is that? Let's look at what side of Earth is turned towards the asteroid at that particular time. And zoom in. This is maximum zoom, guys. Do you see what I see? Saudi Arabia there. I would say that the danger zone is an oval spanning anywhere from northern Saudi Arabia, to Israel on the left, to Turkey and Azerbaijan on the top, and Iran on the right. Once again, here's as close to an impact prediction as we're gonna get. Next up is 2014 RC. We'll do the same with its positioning data as we did with ES4. Now 2014 RC, or RC for short, is the most unlikely of the three to get attracted by our gravity. It is projected to not even come within Moon distance of Earth. But because it might sort of follow us in our wake, I will include it anyway. The green arrow is the distance that RC covers in 7 days. Over here that's 3.7 centimeters. The orange path, though unlikely, is 2.65 times longer than the green path. 9.8 centimeters. This means that from 9th of September onwards, RC would need 18.55 days to collide with us. Actually, it will be less, as its flight would as well be facilitated by Earth's pull, speeding it up. Let's say that because of this, travel time will be 15% less. That's 15.76 days from 9/9 onwards. That's approximately 24th of September 1840 UTC. Let's see which side of Earth would get hit at that particular time. Coincidentally, it's again the region of Saudi Arabia we see popping up. But this time, It looks like the danger zone would have Sudan and Egypt at its heart. Lastly, let's look at 2018 VP1. Again, an asteroid that passes us closer than the moon. Let's plot our own path of flight for VP1 towards Earth. Green arrow is distance traveled in 6 hours. 4.5 centimeters on my screen. The orange curve is 10.3 centimeters. Or 2.5 times more than the green arrow. Once again accounting for the asteroid to speed up by 15% due to Earth's pull. This means it would hit on November 2nd around 12 o'clock UTC. And where would it be that it hits? It's either India or the Arabian Sea. If you are from the mentioned regions or you have relatives, friends, or loved ones there, you may want to send them this video and a word of warning. Better be safe than sorry. The safest thing to do if they were to impact aforementioned regions, would be to evacuate the area with a decent margin of error for the timing part of it. If this was useful to you, any tip is much appreciated. Let's avoid any bloodshed or loss of life. Take care guys and see you next time.